Okay, so looking at this one, the first thing we need to find is that desired value, sometimes called the ideal value. How do I find that value? It's in the middle of them, right? So I add them together. Divide by 2, what do I get? 35,000. So 35,000 ohms, that's my desired value. Now to find my allowance, I can do one of two things. I can either just subtract, so take this and subtract one of these to get the difference, or I can go back to that original range. And we'll subtract off the smallest one from the largest one to get the difference between them, and then divide that by 2. And I get 1,750 ohms. So that's my plus or minus. But right now, that is an absolute allowance. So that is saying, I don't know, 1,750 went. That is saying that is 35,000 ohms plus or minus 1,750 ohms. But I need it to color code it, I need it as a relative allowance. So how do I turn that into a relative allowance? 1,750 over 35,000 is equal to blank over 100. 100 times 1,750 divided by 35,000 is 5. So this is a plus or minus 5%. So I have to color code 35,000 ohms plus or minus 5%. So what number? Now there's going to be 3 bands here. What number goes with the first band? That's the 3. That's the first digit, right? What number goes with the second band? The 5. The third band, remember, is a little different. It's describing the number of zeros at the end. So what number is that going to be? Do 3 again, because there's 3 zeros. So 353. So what color is 3? Orange. What color is 5? Green, and then 3 is orange again. So we have orange, green, orange, and my tolerance of 5% is gold. So orange, green, orange, gold. Make sense? Okay. Today we're going to be looking at reading meters and scales. So for example, this meter here. To read a meter, to read a scale, we first have to know what each division represents. And to do that, we look at 2 marked divisions. Now, I usually don't start from 0, because a lot of times, a lot of meters, the very beginning of the scale isn't necessarily marked accurately. So I usually go between the next labeled marking and the one after that, so 10 to 20. So the difference between those two is 20 minus 10. Whatever units this is measuring. And then I count how many spaces, how many divisions are between them. Remember, divisions are not the lines, as we just said, they're the spaces. So there's 1, 2, 3, 4, 5. Now that's a definite halfway point, an obvious halfway point. So I know that it should be the same on the other side. So I can just double the 5. There's 10 spaces. So I could count them all out, but I'm not going to. So now I have 20 minus 10 is 10, divided by 10. That means each space on here is equal to 1. Does that process make sense? So now that I know that each space equals 1, this is 30, 31, 2, 3, 4, 5, 6, 7. That is reading 37, whatever units that is measuring. It's not uncommon to have meters like this, where as you can see there are 3 scales, 3 different sets of numbers on that scale, I should say. How do we know which set of numbers to read? Got to look at the setting, which is down here. It is set at the middle level. Now, 8, 16, and 24 is talking about the range. This one goes up not quite to 8 volts. This one actually says 15, but that would be the 16 volt setting. The 24 volt actually is going up to 30. But what it's talking about is measuring different types of systems, an 8 volt, 16 volt, or 24 volt system. So anyway, which scale would I read on this one? The top, the middle, or the bottom? The top, or the middle, the 16. So look at that middle scale. I've got 11 and 12. So 12 minus 11, that's only 1 volt. How many spaces? 1, 2, 3, 4, 5. We'll double that, that's 10 spaces. So 1 volt divided by 10 means each space is 0.1 volt. So right now, this is the 12. 12.1, 2, 3, 4, 5, 6. So that is reading 12.6 volts. Any questions on that? This one is an interesting scale. You don't need to know this word, but this is what they call a logarithmic scale. The size of the divisions is not consistent from one to the other, from end of scale to end of scale. It changes as we go. First of all, when you measure ohms, it reads backwards. The needle does start over here, but it moves right to left instead of left to right like we're used to. And you can see here, this is 0 ohms. 1, 2, 3, 4. They get closer together. That actually should be 6. That's mislabeled. It should be 5, 6 like that. So that's just a misprint. 7, but then you can see they start getting really close together. 8, 9, 10, 15. Then it jumps to 20, then to 30, then 40, 60, and then up to an infinite. Right now, it is pointing right here on this line. What line does that? What does that represent? I'll zoom in a little. That is representing 8. Now I got to look down here. This is on times 1,000. So whatever I read off there, it's not like this one up here where it just had the numbers 8, 16, 24. This actually says times 1,000, which is telling us to take whatever we read on the scale, multiply it by 1,000. So I was reading 8,000 ohms. Here, this is actually what we call a change meter. A lot of the old meters, and I realize you guys use a lot of digital for now and don't use the old dial meters anymore. Well, they actually had, I actually have a tensile strength tester that's set up like this. They actually had a idle needle that was actually controlled by a knob. It didn't move with the meter. So you just take a reading. There's where the needle of the meter is. So you set that idler needle over the top of it, and it sits there. And then you change it. You measure something else, and that, of course, the meter moves. So you can see what the old reading was, where that idle needle was, to the new reading is. So here, what is the amount of this old reading? 27. I didn't bother figuring out the divisions because we've seen meters, this meter before. We know that each division is 1 unit. So 20, 1, 2, 3, 4, 5, 6, 7. What's this reading? 41. So then this, what this saying here is the difference between the meter and that idle needle is 14. So it changed by 14 units. See if you can read this one. I know it's not easy in there. One of the problems with analog meters, with the lines are too close. Well, the lines are pretty close here. But one of the problems is that sometimes, yeah, you can see this is the first one here. But if you count, there's 1, 2, 3, 4, 5, only 5 lines in between there. So there's 6 spaces between 1 and 2. Well, that doesn't even work out to nice even spaces, does it? 1 divided by 6, that's, you know, not 0.2, it's not 0.1. It's a weird number of spaces. I would say that that is 1.5. Because there's 1, 2, 3 spaces before that line, and there's 1, 2, 3 spaces after it. So it is in the middle. It's 1.5. But each space there is actually a sixth. Now it's 1.5. What do I have to do with that? Down here, do I have to multiply by 1,000, 100? Multiply by 1, so I'm just going to leave it. That is 1.5 ohms. So for this one, find the change. What's this meter read? 41, and this one, 55. So the change is, just subtract two numbers, 14 units. This is actually an exhaust analyzer. Did you guys do an exhaust analysis yet in the shop? The hydrocarbon and all that stuff? This is one of the old meters for doing that. Hydrocarbons and carbon monoxide are the two things that they worry about. Wisconsin does not have mandatory exhaust testing. California does. I know they exhaust test your car, and if you do not pass, you do not register your vehicle. Or you pay a heavy fine to keep your vehicle registered. So here in the hydrocarbons, there's two scales. Which one am I going to read? It's set on low, so I'm going to read the small one, right? So what's that reading there? Yeah, it's smack between 200 and 300, so that is 250. Over here, top scale or bottom scale? Bottom, because it's set on low again. Yeah, it looks like 20, but it is 2.0. If you look beside it, you can see there's decimal points in those numbers. Has to be one there too, so that's 2.0. Here we have a volt and amp meter. This used to be used a lot, so you measure both at the same time, voltage and current. So this is amps. This one, of course, is reading. This one should be easy to read. 200. This one, however, which scale do I read? Bottom or top? It's set on 20, so I read the top. So it's 8, it's in the 9. 8, 9, 10, so it's 9. So it's 9 volts, 200 amps. I'm thinking there's something, a label missing. It's probably 200 milliamps would be my guess. 200 amps is very, very uncommon. So if it were on the 10 volt setting here, we'd read the bottom scale. What if it were on the 30 volt setting? What would we do? 30 volt setting, there's one of two ways to read it. The easiest way is just take the bottom, whatever it says on the bottom scale, and multiply it by 3. Technically, the way they teach you in industry, if it's on the 30 volt setting, you take the two readings and add them together. But that'll be the same as taking the bottom one and multiplying it by 3. So that's the exact same one, so we're not going to read it twice. Read this one for me. This is 250. Needle's in the same spot. Why is it not 2.0? Because it's on high setting now. That's at 8. How about this one? The 2000, by the way, is indicating that one. Between 1600, this is 1800, is what that mark would be. That says just below 1700, so we're just going to call it 1700. How about over here? 2.0 again. I'm thinking that needle's stuck or something. What's the top one reading? 31. Bottom one, 14. Good. How about this one? First of all, what scale do I use? the top one. It's on the 8, so I'm going to use the smallest set of numbers, this top scale. So I'm going to use this. This is 6, this is 7, right? 7 minus 6, that's a 1 volt difference. How many spaces are there? Well, 1, 2, 3, 4, 5. So it's 5, 10, 15, 20 spaces. 1 volt divided by 20 is 0.05 volts per space. So this is 7.05 volts. Try to read this one in your notes for me. So it's on the 24 scale. So we're going to use the bottom set, the larger set of numbers. Between 22 and 24, so it's 24 minus 22. That's 2 volt difference. How many spaces are there between there? If I count them up, there's 10. 2 volts divided by 10 means each space is 2.2 volts. So this is 22.2, 22.4, 22.6. So that is important to make sure you go through and figure out what each division stands for. Oops. Read that one for me quick. Which numbers am I using? Middle. 13 to 14, so that'd be 14 minus 13, that's 1 volt. There's 10 spaces. So I know that's 0.1 volt per space. So that is 13.1234 volts. And finally, I'll have you read this one. Wow, this one's easy. It's on the center setting, so each spacing is how many volts? 0.1. So this is 13.12345, 0.6, 0.7, 0.8 volts. Now we're going to look at depth gauges, or dial indicators. This is, you can see on the center, it says 0.01 millimeters. So this is reading down to the 100th of a millimeter. What these normally have is down below them. Oops, right there. There's a indicator that sticks out like this. And that, when you push in on it, the dial rotates. And it measures how far it's been pushed in. So this one, it can actually go in or out on some of them. So that's why you have this arrow here that's indicating it's moving in the positive direction. This dial down here indicates how many times it's spun around. Well, right now it's between 0 and 1, which means it has not spun a complete circle yet. Does that make sense? Since this is millimeters, that would be whole millimeters. So right now this is 0 whole millimeters. And these are in hundredths, so this is 10, 11, 12, 13, 14, 15, 16, 17. So 0.17 millimeters. Make sense? So for this one, what are some things you notice that are different here? Yep, it still goes both ways, and here the arrow is pointing this direction, which means that dial has gone around this direction. Now, the little needle has moved 1, 2, it's between 2 and 3, which means it has moved 2 complete rotations. So there's 2 pieces of information we have here that we didn't have on the last one. First of all, this is going in the negative direction, so this is a negative measurement. And there are 2 whole millimeters. So it's -2. Then after the decimal point, this looks like it's sitting on a 19, but it's not. Can you tell me why? It's going the other way. So this is 10, 20, 30, 40, 50. You can see it goes 10, 20, 30, 40, 50 in both directions. So after the 50, we've got to count up. So 50, 60, 70, 80, 1. Have you guys used this type of meter yet?
Well, how does it go to 0 then? Go either way.
Well, there's a 0 point in that indicator, so you either push it in or pull it out.
Well, we got them on a way, like, it goes all the way out. That's 0. So
Most of the ones you'll see, they only push in, so they'll only go the positive direction. But there are some that they're actually attached. They either pull or push. The weird thing is this dial indicator here still goes the right direction no matter which direction it's going around, which I've always thought is kind of weird. Because you'd think if this needle's going backwards, that one would go backwards too, but it doesn't. So on this one, positive or negative? It is negative. We are going in the negative direction. Any whole millimeters? Any whole millimeters? No, we're between 0 and 1, so that's 0. 10, 20, 9. How about this one? Where do we start? Positive, right? Any whole millimeters? Okay, between 1 and 2, so that's 1 whole millimeter. So 1 point what? 20, 1, 2, 3, 4, 5, 6. 26. What's that? Oh, we're going the wrong way. Never mind. How about I read it the right direction? You are correct. So this is, 50, 60, 70, 1, 2, 3, 4. Nice catch. It is more awake, one of the two. Okay, so for this one, positive or negative? Positive. Any whole millimeters?
1.10.
Oh, Anthony has got the right idea, but can anybody tell me why he's wrong?
I'm not wrong. Oh, okay. All right, Mr. Know-it-all. I read the meter.
I switched the meters on you, didn't I? This one was 0.01 millimeters. This one's 0.001 inches. So what's down here is not a 1, it's a 0.1. And this is thousandths. So that's 10 thousandths. Well, 0.1 from here and then 1, 0. What's that? How about this one? Negative. Now it looks, is that to the 0.9 or not quite yet?
0.8.
It's not quite back to the 0, so just 0.8. That's be 50, 60, 70, 1, 2, 3, 4, 5, 6, 7, 8 inches. Negative 0.878 inches. That's where I'll catch you on a test, is whether it's millimeters or inches. Just like with the calipers, that placing of the decimal point is usually a big mistake. How about this one? Positive or negative? It is positive. So 0 point. Yes, it has passed the 4. 30. 1, 2, 3, 4, 5, 6, 7. You are correct. So 0.437 inches. This one. So it is negative. It is 0.1. And this is 59. You are correct. You caught yourself. That's what matters. Okay, so here is a vacuum meter. What is that reading right there? Oh yeah, this is 2, this is 2.5, and there are 5 divisions in between it. 2.5 minus 2 is 0.5. Divided by 5 divisions, it is 0.1 per division. So that's 2.1, 2.2. How about this one? Well, we got to figure out what each division is. Again, this is 50, and that's 100. 100 minus 50 is 50. How many divisions are between them? 1, 2, 3, 4, 5. So there's 10. That means each division is worth 5. So this is 50, 45, 40. Is what that's at. That's actually DC volts. Yep, go ahead. Your homework is going to be page 209 out of your book. Exercise 4.9. Sorry, I wasn't paying attention. I should have let you go about 5 minutes ago. That means page 209 out of your book. Okay, for this one, what's each division stand for? We're going from, here we'd go from 4 to 6. So 6 minus 4 is 2 units. How many spaces? 1, 2, 3, 4, 5. So there's 10 spaces. So each division is 0.2. So that's 6.2, 6.4. What's this one reading? This is an old meter similar to the one you had before. So it's actually pretty simple. 10, 11, 12, 13, 14, 15, right? That's just a 12. On these where you got that logarithmic scale, that uneven scale, this one's a lot better done, by the way, because it's actually readable. Basically, what you got to do is you got to take the unit before. Readable? Yes.
I didn't know if it was word or not.
So we get 12 volts there, or 12 ohms there, I should say. How about this one? So if we read this one,
1.5.
well, that's 150 there. That's 100. Yeah, your guess is pretty close. I'd say 125's got to be pretty darn close to it.
Yeah.
How about this one?
Uh,
How's that?
500. Yeah.
That'd be the 500 line right there.
Okay.
That's the 1K, or the 1,000 line. Might have to move this one back the other way. This would be 6, 7, 8, 9, 10. That's the 5.5. Like I said, for those, you almost have to just count them out and see if they come out. Go back and adjust if it doesn't come out right. This one's a little more straightforward. Yeah, each of those divisions ends up being 5, right? So this is 100, 105, 110, 115, 120.
A little bit on the purpose side. Not on the paper quite.
Simple as that. So now this one, the first thing we have to do is identify inch or millimeter.
Inch.
Inch.
And it's negative.
It's negative
0.
0.0. 50, 4, 5, 6. You are correct. 56. So negative 0.056. This one, millimeter. It's negative 2.58 millimeters. The question with these 2 meters is the single most missed question on this next quiz. This next quiz that you will have probably like next Wednesday when you guys come back after Thanksgiving. I'm probably looking, it may not even be that week after Thanksgiving, or maybe the Tuesday after that, you'll be looking at Unit 4 tests coming up.
So my question is, are you going to label them like you did on the last test where it says if it's...
No, probably won't.
You got to make it a little more noticeable.